Hello and welcome to the live stream. Let me try and fix up the camera just a little. And there we go. Okay, so today I've received lots of questions on my Patreon. So thank you to the Patreons. There's a few questions on Twitter as well and from various other places. Some of the questions on Patreon are in great depth. Some of them are extremely long, but I owe my Patreons something in return for their great support. So I'm going to move through them one at a time and spend some attention. So I'll be looking off into that direction where there's another screen where I can read what the Patreon questions are. So without further ado, let me just get straight into it. The first one is from Adil, and Adil says, "Hi Brett, what do you think of the idea by Ian Jarvie and Joseph Agassi that making progress towards scientific truth depends on seeking out the next unrefuted explanation, whereas making progress towards technological usefulness depends on applying the best refuted explanation? Reason being, it's not really possible to understand the limits of an unrefuted theory fully until it is later refuted by an even better unrefuted explanation. So designing a technology in light of theories that remain unrefuted, e.g. quantum mechanics and relativity, may be unusually risky because we don't yet understand what their true limits, edge cases are, right?" Wrong. No, I don't agree with this. I think that our situation is that we have problems, and when we encounter problems, we apply the solution that is going to best solve our problem. So when it comes to finding a technological solution and requiring that we only use a hitherto refuted solution, well, I think that's just misguided. I don't think that's correct. And I don't think that's correct because, well, look at any example. What is the GPS system based on? The global positioning system, although you, in theory, could probably make a Newtonian version of it, it relies upon our best unrefuted theory of gravity, the theory of general relativity. And so that's just one example. Many of the bits of technology that we use rely upon our understanding of quantum theory as well. Scanning tunneling electron microscopes are one. The existence of the Large Hadron Collider. Many of the things that exist inside of hospitals that scan you and help doctors to diagnose you rely upon unrefuted theories. So no, I don't think that's quite right. We design technology and we solve problems in the physical world by falling back on whatever the solution happens to be. Let me just check to see if my audio is working. Can anyone in the chat tell me if the audio is actually working? I can't quite tell myself just yet. In fact, I can see that it's not. Bear with me. I can see people were saying it was working, but is it working better now is the question. I had this microphone turned off, so presumably just the laptop was picking up audio. Wow. Anyway, continuing. Yeah, so that's the answer to Adil's question. I know, I don't know personally, I know of Joseph Agassi. I don't know Ian Jarvie. So I can't say whether or not Adil's representing their argument exactly with fidelity, but Well, one part of Adil's question says, the reason that we would use refuted theories in order to create technology rather than unrefuted theories is because it's not really possible to understand the limits of an unrefuted theory. Well, it might not be possible to fully understand the limits in some sense of even the refuted theory. The refuted theory can reach into areas that we don't fully understand either. So that's another thing. But yes, I think it all just comes back to whatever your problem situation happens to be. Routinely we use, I just go back to, of course, the area I know, which is physics. So much of our technology, if you like, and that can include our physical buildings, relies upon our understanding of classical Newtonian mechanics. We don't need to go into the details of quantum theory or even the details of physical chemistry as to how chemical bonding works in order to build a bridge. Sometimes we might, but we can get by simply understanding things called statics in something like civil engineering. And although it's not a fundamental theory, it's a theory that will solve the problem of building the bridge or constructing the building. So I suppose I would have to understand precisely more details about this particular argument, because it seems to me that on the face of it, we absolutely do rely routinely, quite often, on as yet unrefuted theories, namely the best existing theory that we happen to have at any given time. Adil asked another question, which is, when asking, what should I do next, does it all fundamentally come back to choosing, creating the best explanation? This is something I've been talking about recently in many of my podcasts, the relationship between epistemology and the chimera that is probability, a discussion of risk, and the thought about how to make decisions and therefore morality, okay, what we should do next. Does it always fundamentally come back to choosing or creating the best explanation? Well, I think it's quite right there to have put creating the best explanation there, because of course we can't always, when deciding what to do next, choose the best explanation, because we might not have a best explanation. We might simply have no explanation at all. And if we're in the situation where we have no explanation at all, we're going to have to rely upon our creativity. This doesn't necessarily mean that our explanation in all cases is going to be a well-expressed, explicit, hard to vary, good explanation. It can be an intuition. An intuition is just, well, this feels like the best thing to do. You're walking down a street at night and someone's walking towards you, you might have a bad feeling. You don't have a good explanation that the person walking towards you is hostile or a danger in any way. You simply have a feeling and intuition. And so the best choice is perhaps to avoid the person or not. It depends upon your particular situation. Are you a big, strong person who understands martial arts? Are you a much smaller person who's a little bit fearful of walking around at night in a dark part of the city? These are the kind of choices that people make routinely every day. And they don't necessarily require some best explanation, in the sense that we can outline and write an essay that accounts for everything that we're doing, because so much of what we might do is couched in intuitions which are inexplicit knowledge, which include inexplicit knowledge. And so that's what I would say about that. Okay, moving on. From David Hearn, a great friend of the podcast. And as I've said before, a great Twitter follow. If you can find David on Twitter, David Hearn, David has curated amongst his many likes what's going on in science in very diverse areas. So rather than me following lots of scientists, I've said this before, I just follow David, because David follows all the good scientists. And when they tweet something interesting, he retweets it or likes it. And so I managed to keep up that way. And he asked the question, about taking children seriously. David's question is, how best to balance taking children seriously and allowing people less than 16 to have drugs or surgical procedures, even if dangerous? Okay, my understanding of taking children seriously is that the only reason that the word children appears in the philosophy at all is because traditionally they've not been taken seriously. And so it's trying to address the problem why we routinely treat this particular group of people that we call children so differently to everyone else. And it's just received wisdom, false though it is, that these people are somehow lesser than normal people. So we don't need to worry about putting the word children in there or even people under 16 into David's question. So we can rephrase it without any loss of meaning whatsoever to how best to balance taking people seriously and allowing people to have drugs and surgical procedures, even if dangerous. That's the question. It doesn't matter what their age is. And what you would do if you care about these people and if you're in the life of someone who is thinking about doing something dangerous, something with a risk, is you would advise them. This has come up recently, of course, for many, many reasons, but among others in the media, people have been talking about this idea of people having surgical procedures to change their gender. At the moment, as human beings, we are confined to bodies, biological bodies, I should say. Off into the far distance, one day, hopefully our minds can be instantiated in something more robust than what we happen to have now, or a version of this where once damaged can be easily and routinely repaired, but we're not in that situation right now. You break a limb, the older you get, the longer it's going to take to repair. And certain things that can happen to you early on in life can have a permanent effect for the rest of your life. Injuries to your spine, injuries to your brain, and so on and so forth. So there's no sense in which we're needing to balance taking children seriously with allowing them to have drugs or to undertake different surgical procedures. Like anyone else, we explain to them and we take time to help them understand what the risks are with taking drugs and undergoing certain medical procedures. The problem right now with the issue as I see it is that, as far as I understand it, doctors have neglected to do the right thing in many cases by advising people of the hazards of some of these procedures. And that's wrong. That, as Jordan Peterson has talked about this, that a psychologist and a medical professional for so long hasn't been in the business of affirming your problem, saying, yes, everything you think is absolutely quite right. But instead, the professional's role is supposed to help you navigate the problem, to come to an understanding of what the solution might be, rather than saying, oh, you've picked a particular solution. Absolutely. Let me help you enact that. It's not taking them seriously by saying, there might be some errors in your thinking. Let's explore that before we go down the road of chopping off parts of your anatomy. Before we do that, let's consider talking to people who've already had that done and seeing what they might say about such a procedure. Perhaps you should join a community first of people who both think it's a good idea and others who think it's a bad idea. And you should carefully consider, not over a matter of days, weeks, and months, but perhaps years. Now, this is a whole issue, but I don't think that it is especially a problem for people of a certain age. People of every age have problems where if they make the wrong decision, then that decision is going to impact the remainder of their lives. The issue we have with younger people, and the younger you are, is the less you know. And as compassionate, concerned, wiser, older people, we should want to help them understand the good and the bad, potential effects of any decision that they make. So that would be my answer to that. I can see no one's saying that anything's going wrong with the audio, so I'm pushing forward in the hope that everyone can hear me. Benoit Munir asks, copy pasting my question I shared on Twitter in July. Can I ask a question? Not sure how. I'm searching for my words, he says. It's around design, the practice of design and science. I'll try with how design is viewed as merging art and science in a framework. Can it provide a good explanation, solution to a human-centered approach or problem? Now, I can't remember who asked a question about what design is or what the purpose of design is or how to understand design in, I think, a critical rationalist framework. It may have been you, but in one of my previous live streams, this is live stream number 5 now, I did answer a question about design, and I said it's design, the whole area of design, something like architecture, is a really interesting fusion between art and science. It stands at the boundary between those things, allowing for imagination, which is completely unbounded in the arts to some extent, and something like science, where the imagination is obviously constrained by reality. And here's design in the middle, where we can explore what physical reality allows and then be as artistic as we like. I am no designer and I am no artist. So I can't give any advice on how design viewed as merging art and science can provide a human-centered approach to problems. Helpfully, someone else has responded to Benoit's question, and that's Andrew. And Andrew says, I thought about this too. My thinking is design is just knowledge about how tailored something is to its purpose, problem, situation. Bad design has more error and is an objectively worse solution, hard to use, sounds terrible, looks bad, etc. Good design is absent much of the error present in the lesser design. That is why it looks simple is objectively better solution. I think, yes, so fair enough. So if we're talking about what is a good design and what is a bad design, I would leave that perhaps to others. Certainly there's going to be a role for, in design, 2 things as far as I can tell: form and function. Does the design solve the problem? That's key. But also, does it do it in an aesthetically pleasing way? And there is obviously a grey scale there, and different people will have different opinions on that. Although, of course, here, what we say is there are objective standards to form. There are objective standards to aesthetics and beauty. And we can solve the problem of what stuff looks better, not merely solves the problem, but solves the problem in a more pleasing way. Moving on. A question from Vish, and this is far more in my wheelhouse, so thank you to Vish. And this is, hey Brett, I've been thinking about the 2 types of universality that David talks about. There's software universality, the creativity program, and then there's hardware universality. 1, David only proved quantum computers are universal, not classical ones. So why should I even believe in the existence of a universal classical computer? Okay, so the answer to that is that's incorrect. The reason that it's incorrect is because in the repertoire of quantum computers is the capacity to emulate, to simulate the behavior of a classical computer as well. So a quantum computer can do anything a classical computer can do. Classical computers, what universal means is that anything that is computable can be computed by that computer. The repertoire of classical computer, what is a classical computer? A classical computer is something that uses binary digits rather than qubits, is one way of looking at things. In fact, a classical computer can compute anything that's physically computable, including anything that a quantum computer can compute, just not always efficiently, which means some of the problems are intractable. Something as simple as using a classical computer to try and simulate the behavior of, let's say, the electrons in orbit around a uranium atom, uranium nucleus rather, is going to be something beyond the capabilities of the most powerful supercomputer that we have here on planet Earth. It's going to take, pick a number, millions of years in order to calculate the positions and momenta of those electrons 10 seconds from now. But a quantum computer could do something like that. In fact, that's why a quantum computer is so powerful, because it can model the behavior of quantum objects well, efficiently. So I don't think that it's true to say that David only proved that quantum computers are universal and not classical ones. The thing is that once you have this concept of a quantum computer, as I say, within its repertoire is anything that can be physically built. It can compute, simulate, create a virtual reality rendering of any physical object, from atoms through to solar systems, galaxies, people, in theory, and anything in between. And that includes classical computers. And reflexively, the classical computer can, in theory, calculate anything that the quantum computer can do, just in many cases, much more slowly, because it has to do things sequentially. Whereas the quantum computer has this massive parallelism capacity where it can compute many, many things simultaneously and find out the optimal solution in some cases out of all of these different calculations. We won't get into quantum computation right now, but yes, that would be my answer to that. But question 2 from Vish is, even then, how do we know the brain is universal and not just a glorified non-universal computer like a calculator or a washing machine chip? What it takes for something to be universal in terms of computation is very, very minimal. Our brains run a certain kind of software, which we argue is a universal explainer, which means it can explain anything that happens out there in physical reality. And the argument for that is simply a denial of the fact that if there existed such a thing that couldn't be explained by us, that was inherently by us inexplicable, then that's an appeal to the supernatural. That says there's something that cannot be explained. And there have been many versions of this inexplicable thing over time. God was, I suppose, one of the first. This thing that is just so beyond the capacity of human beings to understand that it is literally inexplicable. And today, people who don't believe in God just shift from God to the laws of physics, the ultimate laws of physics or something like that. They might be inexplicable, inaccessible to us in some way, shape or form, because they're beyond our capacity to understand. But understanding is just a kind of computation. How do we know the brain is a classical computer? Here's one way I like to think about it, and there would be alternative answers to this. One way of thinking about it is we can emulate a classical computer. What do you need to do to emulate a classical computer? Well, you emulate a Turing machine. What is a Turing machine? A Turing machine, all it is a strip of paper, in theory infinitely long, that can read and write symbols on a piece of paper and move the read head left and right as required, erasing and then writing these symbols on pieces of paper. All computation classically reduces to this. That's what classical computers reduce to. The capacity to read symbols, erase them, replace them, and move along. And the reason it does that is because it's following some instruction set. You can do that. I can do that. Any human being can do that. They can follow that set of instructions. So the software that runs upon our brain can emulate the action of any classical computer, fundamentally what the classical computer does. So therefore, the hardware on which that software runs must itself be universal because it's capable of doing what the hardware of any classical computer can do. Yeah, so when I was first grappling with trying to understand quantum computation at university, I remember myself laboring under the misconception. I thought, there's quantum computer stuff. So therefore it has a greater repertoire of computations that it can do. And for a long time, I sort of thought that. Misconception. It doesn't have a greater repertoire. It's just that for some tasks, it's stupendously faster. The quantum computer is stupendously faster. Why? Because it's got a different way of computing stuff, a different mode of computation. It's not just reading symbols on paper and then deleting the symbol and putting a new one there and doing that sequentially one after another. No, it's able to combine the results of many simultaneous computations together using interference and entanglement in order to accomplish what it does. Okay, so that's the answer to Vish's question, I hope. Hi, Brett, from Andrew. You have spoken many times how widespread bad epistemology is in academia, public intellectual circles, and how it leads to dogma, misconceptions, and the slowing down of progress. Do you have ideas about what can be done to promote good epistemology there? If so, what are they, and how would you like to see them improve on the current system? Well, I guess the bad epistemology that appears in academia is just one of the many issues with academia, I would say. The entire academic structure is set up in such a way as to hark back to a kind of epistemology, a kind of learning, and a way of organizing organizations that itself is authoritarian. The very notion of having a ranking system implies that there are people who have the special knowledge, the guardians of the truth, if you like, and the rest of us. Naval Ravikant has called it a priesthood, and I think that's a good way of thinking about it. There are great virtues to the university, and I enjoyed my time at the university, and I think the universities have much to be said in their favor. They serve an important function still. However, like many corporations, but worse, they resemble a priesthood in the sense that, well, you've got a pope, don't you? The vice chancellor or the chancellor. You then have the cardinals, perhaps, the emeritus professors or the full professors, the bishops, the associate professors, the lecturers, and the priests, the lecturers and tutors and so on. And then the lay people, the students, and perhaps the rest of the public who listen to what the universities say. And Naval's point in saying things like, well, academia is kind of a priesthood in many ways, is because within the culture of academia as it exists right now, many people are only listened to the extent that they possess the qualifications and the titles. Now, not in academic conferences, by the way. And David Deutsch has made this point many times, that, and I think Sam Harris and various others, if you go to an academic conference and you listen to people deliver their findings from their research for the first time, you're as likely to see arrogance and haughtiness from the top professor standing at the front, telling the assembled audience about their new findings, about what the results from the Large Hadron Collider were, or the latest pictures from the James Webb Space Telescope, or my new theory of string theory, or name your subject area. When the professor is delivering this for the first time, you're as likely to see arrogance and dismissal of questions as you are to see nudity. In other words, you're not going to see that. Everyone is on an equal footing. The undergraduate who has an interesting question during that conference can raise their hand and ask a question. And if they're dismissed by the professor, a world expert in his field, everyone will see that and everyone will realize the professor doesn't have the answer. And that's a criticism of whatever they happen to be saying. Everyone's on an equal footing there at the conference, during the lecture, during the delivery of the paper. However, once we move outside of that and we're talking about the public arena, then the rules kind of change. The situation is different. The media's treatment and the public's treatment of the expert class really is still like a priesthood. And you are deferred to for your opinion to the extent that you have tenure at a university, a long list of publications after your name, books to your name, many students who follow in your footsteps and promote your work and defend your ideas. It's then that the irrationality begins to come in, because then what are we doing? We're no longer relying upon a critical way of trying to come to a deeper understanding about reality, but instead deferring to the person with the greatest authority, designated as such because they have the most experience, the most number of qualifications, the longest list of research papers behind them. Any one of these things that people tend to say indicate the person with the answers. So that's one thing. If your organization, academia, is mired in this idea that one has to look up to the person who is best credentialed, then of course that bleeds into the epistemology and the epistemology that is taught. And so there's going to be motivated reasoning to a large extent in philosophy departments and elsewhere, that what we should be teaching our students is that what everyone should be doing is listening to the experts uncritically to some extent. Now they can talk about critical thinking all day long, but if what it comes down to is we should trust in the experts and believe their pronouncements about the future or anything else, then we've got a problem. Now, how would I go about changing that in academia? I don't know. And the only thing I've been able to suggest recently is that for many, many reasons, because of these difficulties in academia, which include not only deference to the authority of experts, but also a certain kind of new indoctrination that is appearing that may have always been there. I know when I was at university beginning in the 90s, this kind of woke, postmodern, relativist thinking was already there. It was nascent and beginning. And it had probably been there since at least the 60s, just growing and getting worse. People beginning to think that things like science were nothing but a series of narratives, stories and fictions that we tell ourselves, none of which connect directly to reality. This began to come out of the universities, and certainly I heard a lot of it when I was there, and it's only gotten worse. Worse to the extent that what's called critical theory in the universities is, of course, a perversion of actual critical thinking. It's turned criticism in on itself and said criticism itself is a problem. That to criticize an idea is to be disrespectful of certain people, a certain class of people, and so some ideas should be held immune from criticism. A complete anathema to an organization ostensibly devoted to the project of learning and knowledge creation. So we've got that problem. How would I change it? I wouldn't. So what I've been suggesting, and I think many people have been suggesting this, I'm certainly not unique in this regard. There are many great people on social media talking about this, We just need an alternative. If people want to go to university and follow the traditional path, that's absolutely great and fine. And as I say, the universities serve an important purpose. But if only, and increasingly this is becoming true, we had alternatives for young, smart people, different ways of learning not merely the subject matter they're interested in, but also ways of thinking about that subject matter, where they would voluntarily, in an open-ended way, learn about epistemology, physics, biology, anything they like, without following a fixed curriculum. And by doing that, having this Popperian understanding of learning, I think that after a few years of success of something like this, would you get a credential at the end? I don't know. Passing through this system. I wouldn't call it a university system. Some sort of mentorship. People with far more capacity to enact change than I are working on these things to some extent. And as far as I'm aware already, large corporations are less and less focused on the credential and the institution from which people are graduating, and instead focused on things like, can you do the job? Are you creative? Are you a little bit of an out-of-the-box thinker? Never mind, your bachelor's or your master's degree. Who cares? How would you solve this problem? And so I think we might be moving towards that. And we can see the universities are reacting in many ways. People talk about the lowering of standards. I have no problem with allowing whoever wants to go to university into the university. But of course, it does have this effect that if the people most interested, passionate, and capable, because they're most interested and passionate, in things like, and I'll just name the area that I know about, physics, if they're most interested in the physical sciences of any sort and passionate about it, and therefore most capable in those areas, are looking at the universities, seeing what the universities are offering, and coming to think to themselves, do I really want to spend 3, 4, 5, 6, 7 years of my life following this very rigid curriculum, at the end of which I gain a certificate, which will allow me to do what? An apprenticeship under an established physicist, and then, and only then, will I be able to do the research and contribute to finding out something new. Is this what the university experience is going to be like? Traditionally, this is what it's been like. I think many universities are trying to be a little bit more innovative, trying to allow new undergraduates, people straight out of school, to contribute to something like fundamental research, as they should, as they always should have. But instead, university, of course, has just been an extension of school to a large extent. So I would like to see the universities improve in precisely that way when it comes to something like science, allowing the students, rather than sitting in lectures and tutorials, working alongside the accomplished physicists, scientists, graduate students, working on actual research, teaching them how it's actually done. Not telling, the prospective researcher at the age of 17, 18 who's just come out of school, who's really passionate about quantum computation, rather than telling them, well, first you've got to sit through 2 years worth of lectures day after day after day on linear algebra and advanced calculus and the classical mechanics and all of this stuff, learning to program in Python, whatever it happens to be. Rather than doing that, let's take you straight to the lab where the quantum computation stuff is being done, where you can shadow the researcher and ask them questions. Of course, the researcher might say, they're getting in the way, but maybe there's some way of hiring people who are happy to do both, the research and assisting the young upstart who really wants to contribute. I don't know if that's happening many places, but hopefully one day soon, that kind of thing can happen. And people will be extremely passionate then, coming out of school and wanting to get into a science course of some kind, where from day one, they're working alongside people who are doing the science rather than just learning, the history of science, essentially. Let's get going. So I think I'm saying that rather than changing the existing system, which is like trying to turn the ocean liner around when it's at full speed, having an alternative, providing passengers with speedboats that can do something completely different. Let the people stay on the ocean liner going off into their direction. There's a reason for that. There's a reason for the old traditional system. There's absolutely no reason why the university system shouldn't have competition for nurturing the best and brightest, teaching the best and brightest, and helping the best and brightest do something different. There we go. Andrew has another question. His question is, not a specific question, but have you listened to the discussion between Lex Fridman and John Carmack? No, I haven't. They talk about John's push into AGI research as a full-time pursuit. Much of his thinking is optimistic about AGI being possible. Well, not only should he be optimistic that it's possible, but there's no need to be optimistic on this. It is possible. One can be optimistic about how soon it's going to happen, but it is possible because we exist. AGI being possible on other substrates and achievable in the near term. Well, even giving probabilities of 55 to 60% by 2030. Or just on that point, I think people will know, if you've been listening to the podcast recently, what I'll say about that. There's no need to say something like this. I think that I agree with David Deutsch here that a lot of that kind of talk is just a scam. It's an interesting way to make money. I've said this before, that if you want to get media attention, let's say, then talking in terms of probabilities seems to really help. you say things like, well, there are prominent intellectuals, let's not mention names, who quite happily go out there routinely saying things like, there is a 95% chance that within the next 50 years, AI will take over the world. And so we need to prepare for this because it's 95% chance. I'm a professor of philosophy at Oxford University. No one ever asks where the 95% comes from. No one ever asks how this, they might say something like, well, we had a prior probability and we took into account certain evidence given the trends in recent production of silicon chips over in South Korea. And anyway, our Bayesian reasoning has led us to this number of 95%. They'll probably tell you a story like that. The fact is, I know that I've been researching this heavily recently because I've been trying to get to the bottom of where do these numbers come from? And here's the answer. Subject matter experts. It's their opinion. They pluck the numbers out of their ass. They just make it up. But because they're subject matter experts, we place great stock in their ability to come up with a precise number. And it's just not true. I don't care if you're a professor or an engineer or the world's richest person. Just because you say that there's a 50% chance of this happening or a 95% chance of this thing happening within the next X number of years, it's no better than the person on the street that I ask for their best guess. You can't know the distant future when it involves the knowledge yet to be created yet, because that's inherently unpredictable. Better to say things like, look, this thing is possible, we're working towards it, who knows what's going to happen. Could there be a disaster? Yes, there could. When? We've got no clue. But hey, it is a risk, so maybe we should start preparing for it. I think that's the kind of conversation that people should have. But instead, because it sounds more exciting to say the thing's going to happen within the next 50 years or 20 years or 10 years. That's exciting. And it sounds scientific, mathematically precise to put a number on it, even if the number's completely made up. You sound very erudite. It's a 96.4% chance that within 23 years, the next pandemic will happen. Because we've looked at past trends, that kind of thing. Pandemics happen this often. But when the next pandemic happens, its severity will depend upon the knowledge we've created over the next number of years about how to deal with viruses and things, how to more quickly mass produce vaccines, how to go about doing other stuff, masking and distancing or whatever else we might invent in the future. I was listening to Will McCaskill talking to Sam Harris. Let's not go down the road of all the disagreements I had there. There was another a wonderful exposition of mainstream pessimistic thinking. But one thing that they did talk about and touch upon was Will McCaskill talking about UV light of a certain kind, UVC light, that might be able to be ubiquitous, harmless to people, but deadly to viruses. And if you could put this in places in buildings all around the world, this could be a great way, an absolutely wonderful way of destroying viruses that might otherwise cause pandemics, or certainly slow the rate at which they can cause damage. Yeah, that's just one thing. So it's very difficult to predict anything in the future, even if we've got so-called trends of the past, data about the past. The past does not resemble the future. I'm sorry, Andrew, let me just continue with your question here. So this fellow, John Carmack, Andrew says of him, he's optimistic about AGI, but he entirely dismisses the moral implications of personhood, consciousness, qualia, etc., as Deutsch and yourself talk about in relation to AGI. John is a brilliant engineer and could make genuine contributions, but they will be without much thought to the potential moral implications of his work. And some references. Thank you, Andrew. And excuse me just while I have a drink of my milkshake here. I don't know John McCormack. I don't know him, but I'll just say this. If you think AGI, if your conception of AGI is that it can be divorced from personhood, consciousness, and qualia, then I just think, on my understanding of AGI, that you don't understand AGI. You don't know what it is. AGI is just a term for a person that hasn't evolved via the means of evolution by natural selection. We can imagine alien life out there somewhere else in the universe. It won't be AGI, but it will be GI, it will be general intelligence, it will be a person, as we are people. AGI is just a person who has been created by already existing people using technology. That has to be possible. It has to be possible to emulate general intelligence because we have it. Because we have it, it's physically possible. If it's physically possible, then we can do it if we know how. That's the whole problems are soluble thing. The only difference between a problem being solved and not is knowing how. So I'm just afraid to say that this idea that of dismissing the moral implications of AGI is a terrible moral failing. It's wrong to do that. And this is why some of us are concerned to some extent about the project of AGI. Now, I'm not that concerned right now. I don't think it's an urgent problem because I don't see anything on the horizon that suggests that AGI is around the corner, that we're just a few more incremental steps, we're going to be there. But let's say we lived in a world where someone had a good explanation that they could create AGI in a computer. My feeling right now, look, they could evolve it in some way. Let's say you could simulate a virtual universe. And in that virtual universe, inside of a computer with sufficient memory and processing speed and all that, you can have galaxies, and in those galaxies were stars, and around those stars were planets, and on those planets were environments that allowed for life to evolve. And you could rig it so that intelligent life would evolve. Would you do it? Many of us would say, no, that would be abhorrent, you shouldn't do it. Now, why? Well, effectively, you're performing an experiment which brings into existence untold suffering that didn't need to be there. Oh, yeah, sure. Some of those people that evolve in that virtual world might go on to have great lives. But that doesn't matter, because what's also going to happen is lots and lots of suffering. Unless you can rig it in such a way that there's not suffering. But then you've got this problem. And this is what I would be concerned about if you had AGI in a simulation, is that the right thing to do would be to tell those people in the simulation that they're in a simulation. They're not they're real people, but the world they occupy is not made of atoms. It's running on a computer. And for them, that would be a terrifying thought, because what if something goes wrong with the computer and it switches off, then they vanish and disappear? So that's the kind of thing that I would be worried about if it was possible. But we're so far away from anything like that that we don't need to be concerned about answering that question right now. But this is also why, related to this, is even if you could have a cyborg that exists in our world with a physical body that could have artificial general intelligence, would I then want to create that? I think there are just many, many questions we need to answer morally before going down that road. One of which is, if you did really create the person like that, would that person be happy that they've been created with a body such that they can't interact with the rest of humanity, all the other people on planet Earth, or be treated in the same way? Let's face it, they would be freakish. They would be different. They would be unusual, and they might not want to be. They might want to go off and, do poetry and have a family, but they can't. They can't. Maybe they can create other little AGIs, but they're going to be brought up in a culture where everyone else is biological. So we need to kind of solve this kind of problem. Now, of course, it could very well be the case that, as David Deutsch says, if you're at the point where you've got the technology to create an AGI made out of silicon, you can make this cyborg thing, then presumably you understand the program for a mind, for creating a mind. And so maybe you also have the technology where you can scan a person's physical brain, biological brain, and stick that into a cyborg as well. Maybe vice versa. Maybe you've also got the technology to genetically engineer a body with a brain but no mind, and you can stick an artificial general intelligence into that. We're in the realm of science fiction right now. So these are interesting moral questions. I think they need to be answered. We have to understand many things morally before we actually solve the problem of AGI. But as I say, although I think it's possible, I see no signs whatsoever that we're anywhere near or anywhere closer. I think that David Deutsch's paper that he wrote on this, I guess close to a decade ago, about how AGI is possible, but we're not there yet, is as true today as it was then. I don't think there's been progress made. I've been trying to follow some of what's out there about this. And almost all versions of it, except for a few people within the community of critical rationalists. There's some people there that are working on AGI via a Popperian perspective, but they are a very, very, very small minority. The overwhelming number of people think that learning occurs via some method of Bayesian reasoning. And so that's a dead end. We know that's a dead end because induction's a dead end, and that's not how knowledge is created. Therefore, it's not how learning can possibly happen. So that can't possibly be a solution to this question of AGI. Now, I'm interested in AGI. I don't think it's a particularly urgent problem. I'm happy with incremental increases, fast, but incremental increases in plain old AI. I think that's fun. But in the distant future, AGI is going to be a thing. And it's also going to make these, just on a related point, it's also going to make moot all of these concerns that people have, very bright people, including the world's richest man, that people very worried about population collapse. I don't think this is an issue. I'm not worried about this, precisely because I think that before all biological life is extinguished on Earth, I think we'll probably solve that. We'll solve that problem of AGI. And so once we do that, or once we solve aging, is another issue. If you solve aging, you don't have to worry about a population collapse, right? Because everyone just continues to live indefinitely. So it's not like you need to replace people because no one's dying, or almost no one's dying. The population will only ever increase. But many, many people are animated right now that that the trends in population growth are going in a direction they don't like, and they're concerned about the species of human beings declining in number. Well, we're not declining in number yet. We're not declining in number yet. We're still increasing. It's still an exponential increase. The rate of increase is decreasing in many, many places, certainly in the Western world. But why people are so animated and concerned about this, I don't really understand. The problem is death more than a lack of birth. If we can solve the problem of death and decay and decline and all that sort of stuff, which are real problems, then we don't need to worry about how many more people are being born. I would love it if lots more people are being born, of course, because I think people are creativity instantiated. They are literally little universes of creativity. The more of them, the better. Let's have more people. But although I think that's a wonderful thing, I also don't think it's a problem if people choose willingly not to have more children. It's up to them. And the bigger problem is, let's keep these individual little universes, people, living longer and healthier. That's the urgent problem. Yeah. Next question from Mikhail Jacobson. Again, happily, more in my wheelhouse again. He asks, question 1. When explaining the many worlds interpretation, I can't recollect hearing you elaborate on why the branches or histories of the multiverse, or whatever is the correct definition, would interfere with each other. Is that because there is currently no theory for that? Well, what's doing the interfering in these situations are individual particles. So individual particles interfere with themselves. And so effectively, that's what we're talking about when we're talking about universes. The use of the word universe when it comes to discussions of quantum theory can be misleading, because what people tend to envision is a thing like our universe, this 13.7 billion year old thing that extends off, billions of light years in all directions, this big solid block thing that happens to exist, that contains all the galaxies. So they imagine that, and they imagine the multiverse is that, but just lots of them. That's not quite right. Although there is that, there is our universe and then lots of versions of that universe, and there are other universes. If you look at the work of someone like David Wallace, who wrote The Emergent Multiverse, whenever an interference experiment is done, you've got little universes being created, differentiating and then recombining. A quantum computer, inside of a functioning quantum computer, are many, many universes coming into being, differentiating, combining. But in terms of physical size, they're as small as what the quantum computer is. So long as they are isolated from the rest of physical reality, because if they're not, then decoherence happens and the quantum computer stops doing what it's doing, stops being effectively able to do what it's doing. Then you've got these universes contained within this little space. So to talk about the many worlds interpretation as being a thing where whole universes or branches or histories are interfering with each other can be misleading. The interference is going on between particles. Now, why? Well, it's simply because for any individual particle, there are instances of that particle. And the instances of that particle, think of the twin slit experiment, take all possible paths that can be taken, do all physically possible things that that thing can do. And under that condition, can sometimes interfere with each other because that's just what happens. Now you might say, well, that's unsatisfactory that that's just what happens. But to use a phrase from Wittgenstein, your spade is turned. Sometimes you get to the bedrock of what we understand. So to an extent, I would agree with you that maybe there's currently no theory for that. It's kind of like if you ask me the question, and this is a question now sometimes I still struggle with myself. You ask, why do two negatively charged particles repel one another? Take two electrons, they repel. They're not attracted. They repel one another. You bring them closer and closer, they repel more and more strongly. Now, Feynman's answer to this, and the quantum chromodynamics answer to this, quantum theory's answer to this, is each electron emits photons. And so because they emit photons, as you bring them closer and closer together, then they're repelling because photons have momentum that cause them to move apart. So this electron's going over here and it's emitting photons that way, and this electron's moving this and emitting photons that way, and so they push each other apart. Why are they emitting photons? Well, then we get quantum field theory, and that gets beyond me. But eventually you get to a point where you go, that's just what happens. That's just what happens. Why, when you cool water below its freezing point, does it turn into a solid? Well, because the little water molecules are shaped like boomerangs and they arrange themselves such that they, the positive part attracts the negative part. Why does the positive part attract the negative part? Well, again, we come back to electrons doing something. It reminds me a little of Feynman himself being asked this question. Famously, there's a great YouTube video of I think the reporter asking him, when you put two north poles of a magnet together, they repel one another. Why? And Feynman says, what do you mean why? That's what they do. They repel one another. And the reporter, or the person interviewing Feynman, actually gets a little bit upset. He gets a little bit angry, and he sort of says to Feynman, I find, words to the effect of something or other like, I find you being a little bit obtuse. I don't understand why you're just not answering me giving me a simple answer. And, I can't remember exactly what Feynman's response is, but basically the idea is, well, that question goes really, really deep. This is why people spend years doing physics to try and understand this stuff. And so you, having not studied physics for years and years and years, come with a certain amount of background knowledge. Richard Feynman has a certain amount of background knowledge, which is vast. But if he goes into trying to explain quantum field theory to you as a starting point, you're just going to ask more and more questions, why, and that's legitimate. It's legitimate, but pushed for time, and you just want a succinct answer. All we can say is that's what they do. So to here, why should interference happen at all? It does because particles exist in multiple instances. And because they exist in multiple instances, sometimes those instances may not be at the same place at the same time. But there is an opportunity for them to come together, to be in the same place at the same time again, and they carry momentum and they can bump each other out of the way. There can be physical collisions between these instances. They can recombine or not. And this process is something like interference. Why do particles exist in multiple instances? There we go again. Interference is a tough one because it's trying to explain using particles what people have traditionally understood, something that only waves do. Okay, why it's rather trivial to explain why waves interfere with one another. The concept of superposition with waves, with the wave theory of light, among other things, is easy. And so people still, even when teaching quantum theory, will speak in terms of waves. That's why we talk about wave-particle duality. Two waves that meet, when their crests combine, increase their amplitude. But when a crest meets a trough, the amplitudes cancel out. So that intuitively people kind of get that form of interference, these waves interfering with one another. But the analog in particles, which is what is really going on, what's really going on when you've got light is not light waves. Although the wave theory of light is easier to understand and appreciate, what you've actually got going on is photons, particles of light coming together and either reinforcing each other or cancelling each other out. Now, how does that happen? Well, there we go, quantum theory again. For what it's worth, there is my series on YouTube about the multiverse there. I think it's got 5 episodes, many hours worth. And I do try and explain there in some detail some of these experiments which involve interference phenomena following what's in the beginning of infinity, the idea of fungibility, and following what is in the fabric of reality, which is certainly where I was persuaded for the first time that this is how you understand this stuff, this many worlds interpretation, the multiverse. Question 2, however, from Mikhail is, if the branches interfere with each other, they should also affect other histories. Does this mean our choices in our branch affect other branches? This concept of branching is sometimes used when certain people explain the multiverse. They endorse this many worlds interpretation, this multiverse idea, but they talk of splitting and branching and so on and so forth. What's actually happening is differentiation. Now, you might say, so universes that are the same, identical in all respects, fungible is the word that is used. These universes exist. And so you right now and the universe we are all in sharing, there are many identical instances of it. And in a very real way, you are all of those identical instances right now, as is the rest of the universe. But every single moment, things are happening that cause all of those instances to differentiate, or those universes to differentiate into different versions. And so you can call that branching if you like. Now, the question is, do those branches interfere with each other? Yes, they can go off and, there can be other kinds of interference. It's not just our universe that's doing the branching and the interfering. There's nothing special about us. There are other observers in other universes. This is the problem. This is one of the problems that the many worlds interpretation, Everettian quantum theory, solves. There's no special place for the observer. The observer obeys the same laws of physics as every other physical system. So if it's possible for there to be two versions of the electron, two versions of the universe, it's possible for there to be, and there really are, two versions of the observer. Now, your consciousness and how your consciousness relates to that is an open question. Why are you conscious of this particular version, but not that one that just differentiated right now? Well, that we don't know. We don't know what consciousness is. We can't pose the problem precisely. One day we'll know. I don't think it's a special problem. I was convinced there for a while, this is an especially difficult problem. It's especially difficult to put the problem, I suppose, but there are many such problems like this. You know, are there a superset of laws of physics that constrain what the laws of physics are that we know? Is there a meta set of laws of physics? Is there a point worrying about this? What sets the values of the constants of nature or the strengths of, you know, these are interesting questions, but sometimes they're difficult to pose. Okay. Next question. Question 3 from Mikhail. I am confused by your rejection of current mainstream reasoning regarding theory. What is the downside of current mainstream thinking, and what is the upside of your way of looking at possible outcomes? I think there might be a missing word in Mikhail's question there. I'm confused by your rejection of current mainstream reasoning regarding theory. What theory? Okay, so is it quantum theory? Mainstream reasoning regarding quantum theory? Because it's following from questions already on quantum theory. I don't know. But let's just deal with the second part of the question. What is the downside of current mainstream thinking, and what is the upside of your way of looking at possible outcomes? Maybe it means probability theory. That's what I've been talking about a lot recently. Okay, it's not my way of looking at things. Most of the time I'm drawing on a number of people, you know, primarily Karl Popper and David Deutsch. What is the downside of current mainstream thinking? Well, just broadly speaking, I've already talked about this, so we'll just check this off as, I think, one of the main, two main issues that I've been focused on recently. One is deference to authority. So therefore, an uncritical attitude to any area of knowledge, from policy making through to morality and science, history, all that sort of stuff. People relying on authorities, that's one thing, and probabilistic thinking on the other. Now, my series on Pinker's book, Rationality, is trying to go into, it's becoming increasingly an assessment of what passes for mainstream thinking, as the question there says. Now, I can't put a number on it, there's no percentage, but there's a lot, of course there is a lot in mainstream ways of thinking, academia, intellectual culture, that's absolutely fine. Because only through trial and error and the encounters with reality that experts have had over time have these methods of thinking improved on what went for intellectual thinking in the past. In the past, the deference to authority was far worse than what it is today. Today, it's a much better version. In the past, it literally was just do as you're told in the tribe. You're a member of the tribe, but you're not the chief and you're not the medicine man. Do as you're told. We have direct access to the gods and the truth. You'll do as you're told. Now, we've moved on from that. But we inherit some of that. We inherit quite a bit of this style of engaging with each other and with reality. That there are certain people who are kind of like, we treat as kind of like portals to reality. Scientists are one such. Scientists are a certain kind of expert with knowledge. And we should value and respect people with expertise and knowledge. But this does not mean that you should give up your own critical thinking faculties and effectively outsource them to someone else. You yourself should be critical and have a good explanation as to why any particular expert is themselves a good critical thinker. that should be the attitude that people typically have. My concern about mainstream thinking is there seems to have been, well, I think it's just been more obvious over the last few years. It seems like two things have happened, and they haven't been for the good. One is one side of politics has been talking about what the experts say more and more and more, and talking about expert consensus and holding up the science. Which is not a good thing, not a good thing to have an uncritical attitude of thinking that the science is settled and that there is a class of people, the experts, who have special insight into things like how the future is going to unfold. I think that's wrong. I think it's bad. I think it's a misstep. And one measure of it being a misstep is there has been a reaction as equally unreasonable, which is to turn around and say, we reject all expertise and none of it can be trusted, and it's a great conspiracy, and you should go to this website where the truth is. Both of these attitudes are wrong, and they're feeding on each other. One side is saying, look at those fools over there, they don't trust the experts. And that side is saying, look at those fools over there, they're a bunch of sheep being led by the experts, the so-called experts. There's a middle ground here. There's a third way. There's the capacity to admit that there is a thing called expertise. And we can admit that the experts should tell us their best explanations and explain it, however long it takes, by whatever means it takes, from as many angles as it takes. Explain precisely what your position is, why you have that position, what you think is going to happen, and allow us to come to our own judgment about things. We shouldn't dismiss the experts out of hand, because to some people it seems as though they are all engaged in some great cover-up and that there's some sort of political bias. There might be. But the only way of being able to uncover bias, errors in general, is for people to be very explicit about what they know and how they've come to know it. And in recent years, it's been a real problem that there's a class of people who haven't even bothered to worry about the explanations. That instead, what they say is, aha, here's Professor so-and-so, and Professor so-and-so is saying that this is the biggest problem that we have, and here's the solution. And anyone who disagrees is disagreeing with the science, with the expert, never having heard or been given the opportunity to hear the explanation. And sometimes worse, the expert pretending they have an explanation when they don't, pretending to know things they don't know, and therefore undermining the expert class, which I think is a terrible thing. I think that in certain areas, some scientists and other experts have been their own worst enemy. They don't need to overreach. And again, this comes back to this probabilistic thinking I've been talking about so much recently. That experts can, it's anti-rational. They can shield themselves from criticism by couching things in terms of probabilities. Because if you say there's an 85% chance of this disaster happening, and the disaster doesn't happen, as invariably it doesn't, you can turn around and say, well, I never said for sure it was going to happen. 85% means 85%. There was a 15% chance it wouldn't happen, so I'm still right. They're always right. Probabilistic thinkers can always be right. They can't be refuted, because things either happen or they don't. And this has been a problem. This Bayesian reasoning is hurting domains of expertise. It's hurting scientists. It's hurting scientists because it's causing them to speak extremely confidently, but at the same time having an out by quoting a percentage which isn't 100%. Instead, what they should be saying is, this is the best known explanation. This is what we understand right now. We could be wrong. But if we're not wrong, this terrible thing is going to happen. We should take it seriously right now. We can always be wrong. Anything can be wrong. We need to be fallibilists. But being a fallibilist is not saying that we don't take our best known theory seriously at any given point. Quite the opposite. It's saying that we could be wrong, but we've got nothing else to rely upon right now. It's either rely upon our best theory or rely upon a not best theory or no theory at all. We need to act. We need to decide. But when people don't give explanations and instead say something like, as emeritus professor of whatever, I am telling you there is a 72% chance that within the next 10 years, this terrible thing is going to happen. Give my foundation $450 million, government. And then the thing doesn't happen. People are right to be very skeptical about that expert. And unfortunately, that subject area. And it should never have been that way. So there's error on all sides. There's error on the side of the experts not explaining themselves well, of couching the way in which they speak in an overconfident way using bad epistemology like Bayesian reasoning, relying upon so-called trends of the past, being consistently pessimistic prophets. And as we say here, prophecy, claiming to know what the future holds, always has a bias towards pessimism, because it's far easier to imagine into existence the terrible tragedy, but not the solution, the explanation which will solve that problem in time. Often not by the expert, by someone else, by some entrepreneur or business person who's seeking to solve the problem, make a profit, and make everyone's life better. So that's another thing. Okay, next question. The next question is from Finn, but what I'm going to do is I'm just going to take a 1-minute break to get some water, which I've neglected to bring myself, and I shall return with Finn's question. Finn's written a bit of an essay, so I don't know if I can get through all of it. And then if there are any questions on the chat and on Twitter, I'll come back and do that as well. So bear with me. Okay. Finn asks, bear with me. He says, hey, Brett, here's the theory of everything. Would love to see a video of your take on it. Now, Finn, I apologize. I'm not going to be able to get through all of this. I skim-read it earlier, and my broad take on this is that diverse theories from different areas can sometimes inform one another, but we have to be careful to apply the best theory for a given problem situation rather than see parallels via analogy between different things, which I think might be what's going on here. So Finn says, and he's, because Finn's a Patreon, I will read through his things and finally get to, I think there's a question at the heart of this. And he says, Sam Harrison mindfulness guides on his Waking Up app talk about how we can't control thoughts or feelings popping up, and we find peace of mind and truly being mindful when we are simply letting our mind do what it's already doing and not grasp at a certain state. One may even experience a loss of self or non-duality or feeling of connectedness to a consciousness greater than themselves if you're doing it right. Side question real quick. Would you say you have experienced this experience yet? Yes or no? Yes, this concept of selflessness is well known in mindfulness and meditation and that kind of thing. The purpose of mindfulness, I would say, Naval hits the nail on the head as close as anyone, as far as I can tell, which is that what you're after is freedom from mind sometimes. That's what we're after. Not all the time. I mean, the overwhelming majority of my waking hours are about engaging in fun, joyful, happy problems, thinking and reading and talking and all that sort of stuff. And so that's not freedom from mind. But when people are in distress and when people are stressed out and when people have anxiety and depression, all that sort of stuff, what you want is freedom from that. You want freedom from your mind because they're just thoughts. And if you can get that state, then you are relieved. Now, of course, if you can replace that with a happy and joyful state, so much the better. Yes, so a lot of people have had the experience. It's well known. I think people make a lot of it. I don't understand why. It's just an experience. It's just an experience to have the experience of selflessness, of divesting this sense you have that you are a self. Now, where I differ with other people who engage in these kind of practices is that I'm not an empiricist. So, and I think maybe you come to this, or someone else maybe has asked, and someone else on Twitter, a question I've been asked hundreds of times, literally. Yeah. Isn't there one thing you can be sure of? That you are conscious, that you exist? No. Just because you're having an experience doesn't mean necessarily you know what's going on. You know the nature of that experience. That's empiricism. Empiricism is the idea that you derive knowledge from experience, from observations. That's true in the physical world when you're looking at my trope example of stars at night and you're seeing them twinkle and you go, well, what I'm observing, what I'm experiencing are tiny, cold pinpricks of light. But that's not knowledge. That doesn't tell you what you know stars actually are. What we know stars are huge furnaces burning via fusion power, hydrogen into helium in many, many cases. You don't get that just by looking at stars. The idea that you do is empiricism, and it's why empiricism is wrong. So much of what we know is explaining what we see in terms of stuff we don't see. Knowledge doesn't come via the senses. The purpose of the senses is to provide the observations that decide between the theories we've already guessed. That's true of the rest of physical reality, and it's true of your own mind as well. It's true of your own mind as well. I know this is hard for people to accept, but get over it. When you look at the table, you don't see atoms, but you know they're there. As much as you feel the table, and I can feel the table here right now, feeling it over and over again never gets me one jot closer to feeling an atom, because it is beyond the capacity of my senses, my sense of touch. So when people are apt to say that they have experiences while meditating that give them certain insight into particular knowledge, all I can say is, why have you changed the epistemological rules? We know that having an experience is no guarantee that you've got access to the truth about reality. You have to interpret what the experience means. Now, this question of, can't you be sure that when you're conscious that you exist? So much is contained within that statement. What does conscious mean? What does sure mean? What does putting these words together into the sentence, I am sure that I'm conscious right now, mean? Once you say yes to that, yes, that's the one thing you can be sure of, well, then you're also admitting that there is such a thing as certainty or surety. Okay, let's say the way it's usually put is, there's one thing you can be certain of, you can be certain you exist. Okay, let's say you say yes to that. Yes, that's the one thing you can be certain of. But doesn't that entail that there exists also, in addition to that claim, there exists something called certainty? Well, it does. Doesn't it also entail that the letters CERTAIN label this concept of certainty with absolute certainty? After all, if there's an error anywhere there, if there's a mistake in you thinking that that's this set of characters label this word certain, which means cannot be mistaken about, and that applies to your existence and your consciousness. Suddenly, what I'm saying is, you're not just certain of this one thing, you're certain of a whole raft of things entailed by that. And I reject that. I reject the concept of certainty. It's just a feeling. You can be in error. What I would say is, I don't know what consciousness is. I don't think certainty is a thing. I think it's superfluous to our needs. And instead, when someone says, isn't there one thing you can be certain of, that you exist? My response is, no, but I know I exist. I know I exist. I don't think I'm mistaken about my existence. Can you doubt your existence? Well, I suppose so. Maybe I've just come into being and I'm about to go out of existence now, and I already did go out of existence. I'm a Boltzmann brain or something. Something ridiculous. I don't need to be certain. I don't need this. Why does it matter? Do you know why it matters to people? Because they want a foundation. They want somewhere to start. They want this solid foundation so that they can then build and therefore derive the rest of the edifice of knowledge. This was Descartes' great project. And some people haven't moved on, as if Popper never existed. We don't need certainty. So I've experienced this experience of not having a self. Finn. Now, Finn goes on to make some claims about what meditation entails. about it providing a greater sense of peace after you've meditated. It can provide a solution to a problem you might have been working on. It might provide you with a new and interesting idea. Okay, and I agree with all that. You know, people who quieten their mind in any way, shape, or form can tend to become more creative, can find the solution to the problem that's been plaguing them. Okay, we all agree. He then says, now here's the kicker. What if the process happening during meditation, when one is connected to more of consciousness than just their mind and body, is quantum entanglement with the parts of consciousness with which they feel connected to? This could mean momentary connection or entanglement on the small scale connection between a person's mind, body, and a piece of clay when they are in a meditative state, while creating pottery, or potentially a momentary sense of entanglement on the grand scale of connection to all life on Earth and matter in the multiverse, while someone is in a deep state of meditation. So what I want to say about this is that it has the same feel and theme to many yogis and mystics and the various other people who try to draw parallels between some stuff that's true about quantum theory and then some stuff that's true about meditation and subjective experience. And I just don't think it's necessary. I think that you can have all of the good stuff that meditation provides without ever worrying about what its connection to physics is. Maybe one day we'll have a good explanation. But it's almost like, to me, meditation can be a valuable experience for people, just as riding a roller coaster can. But the fun of riding a roller coaster is not really enhanced, I would say, by having a deep knowledge of the laws of physics. The laws of physics mandate everything that happens. They can help to explain certain things that happen, but they can also be utterly irrelevant to whatever you happen to be doing. You can be a great surfer without ever understanding fluid dynamics. You can have fun while surfing or swimming without knowing about the chemistry of water. So too here. Now, could meditation have something to do with quantum entanglement? I mean, it could, but there's a couple of reasons why I would say it's extremely unlikely. One reason is, just at a technical level, is that quantum entanglement is this idea where you can have two different things, two different atoms, acting as if they're one, essentially being the one system. They're entangled. Now, the way that occurs and the way that can be set up in the laboratory, my understanding is, and I may be wrong, there may have been advances since I last looked into this, but quantum entanglement is important in things like quantum computation. Very important. Models of entanglement, physical model, actual existing demonstrations of quantum entanglement, happen for individual particles or pairs of particles or groups of particles when the temperature is exceedingly low. Why? Because you need the system to be isolated from the rest of physical reality, and thermal energy, heat, the vibration of other matter around, can cause decoherence, can cause whatever information is contained within that system, which is so entangled, to leak out into the rest of the world, losing the entanglement, destroying the entanglement. So the brain, the human mind, but the brain is a very hot place in comparison to near absolute zero, which is where quantum entangled systems happen to be. Now, smart engineers are working on this, and they need to work on this in order to realize a proper quantum computer. And there might very well, they keep on increasing the temperature at which superconductivity works, for example. It used to be that, superconductors were all sort of pure metals like copper, cooled to, minus 270 degrees Celsius or something like that, near 0 Kelvin. a few degrees above absolute Kelvin. Pure metals, they were the first kind of superconductors, I think. But then gradually over time, smart materials scientists began to invent things, ceramics and other kinds of things, where the temperature didn't have to be near absolute zero. It's still very cold, but maybe, certainly well within the temperature range of liquid nitrogen, okay, which is only like minus whatever, 180 degrees Celsius or something like that, and very cheap. So you can have superconductivity at a considerably higher temperature than absolute zero or near absolute zero. So hopefully one day, if the progress is happening, unless we discover new physical laws, we will have superconductivity at room temperature. That'll solve a whole bunch of problems with energy. And quantum computation will be happening at room temperature as well, perhaps, or certainly much higher, functioning quantum computers happening at a much higher temperature than what present experimental versions of them are operating at. And most experimental versions I'm aware of that seem legit operating at very low temperatures. I say legit because it's just a story I think I retweeted yesterday. Again, one of these claims that come out. It's at the moment, quantum computation, so much of the industry seems mired in speculation, exaggeration, and hype, which is really unfortunate. But because there's a lot of money out there. Governments are engaged in providing people with funding to try and build the first quantum computer. And so a lot of people are trying to pull the wool over people's eyes, I would suggest, by saying they've got something that's like a quantum computer. And yet again, an article came out, this has been happening sort of periodically over the last decade. I remember this thing called D-Wave. I think this was another example of D-Wave. D-Wave was this computer that was claimed to be a quantum computer. At first, it was claimed to be a quantum computer. Google, I think, bought it. They claimed they had a functioning quantum computer. And a lot of us were saying, wow, that's amazing. Given we were trying to follow progress in the engineering of actual quantum computers, around the corner from where I live, not far in my city, University of New South Wales has a Centre for Quantum Computation. I try and follow what they're up to and what they're doing and how much progress they're making. And they're making progress, but it's exceedingly slow and they're not able to do much. And so I've kind of got an idea of what the real people who are publishing stuff in actual journals where you can go and check the results, where they're at. And, they can, they're using like 2 or 3 qubits, single atoms or a couple of phosphorus atoms, using the spin of these phosphorus atoms, spin of the electrons in these phosphorus atoms to do stuff. It's not much. It's impressive, but it's not like they're ready to make desktop versions of these things. And yet companies like D-Wave come out and say, we've got a fully functioning quantum computer. And then a couple of months or years go by and then they kind of admit, well, it's not quite a quantum computer. It's kind of got quantum things with it. But we've got quantum supremacy. And what quantum supremacy is I've never really understood it, but the claim is that quantum supremacy is a demonstration of a calculation or bit of software or something like that, but a calculation or a computation that is done in a certain amount of time, which would be impossible to do by any classical computer. Once you can do that, you've got quantum supremacy. And I've never understood this because I've always thought, well, doesn't that just come down to the programming? And if you really did have this quantum computer, why aren't you just telling us what the plan is of the quantum computer? This is where you get this real tension between the free and open publication of knowledge that traditionally has happened in science with the commercial interests of industry. There's this tension. The same thing happens, of course, in the pharmaceutical industry. Wouldn't it be better if all the pharmacologists around the world just shared openly their plans for different medicines and trials and everything was just open source? Well, they don't want to do that because they're investing lots of money in trying to make the next best medicine, and they don't want the competition to find out the recipe, so they can't publish it. They have to keep it secret, test it, and so on and so forth. So there's this problem, which on the one hand is good for trying to have the best people work on these important problems as fast as possible, but bad on the other hand because it doesn't allow them to collaborate. I don't know how to solve that problem. I don't think anyone's got a solution to that problem. The same thing is true in this quantum computation realm. Lots of people are working with very diverse, different ways of trying to build a quantum computer, a functioning quantum computer, but many of them are not sharing their ideas. They're keeping them very close to their chest, because if they do make a breakthrough, they want to be the first, have copyright, and then sell it for, untold billions of dollars. Great, very well, more power to them. But unfortunately, that very thing could be slowing them down, because person over here and person over there and person over there, and if only they could combine their knowledge, they're working for all different companies, would get to the solution faster. Maybe. But because of the system as it is now, there's a lot of perverse incentives, as people say, of research groups saying they've made a breakthrough, producing, glossy pamphlets on their quantum computer, their latest quantum computer, and saying it has achieved quantum supremacy. And so, I retweeted an article. I can't remember the details, but it was just a case of where another research group said of the first research group, they didn't achieve quantum supremacy. Here's our program running on a normal classical computer that outperforms your supposed quantum supremacy thing. So you never had quantum supremacy in the first place. And by the way, if someone does demonstrate quantum supremacy, aren't all they are doing is just beating any existing computer, which any computer of the future, quantum or not, is going to do anyway. So it's a lot of black box stuff. So this is the practical application of entanglement. I don't think we need to go into entanglement can also explain what's going on during meditation. I think you can have your meditation without needing to worry about whether it's connected to quantum theory or not. Okay, and so Finn goes on to say, well, as he says, the reason it could be, what's going on during meditation, the reason it could be quantum entanglement is because you could be connected to some part of consciousness broader than your mind and body. And so you could be in an entanglement with some part of consciousness broader than your body and mind. And since consciousness is part of the multiverse, you could be in entanglement with some part of the multiverse broader than your body and mind. How can you test if this is true? Well, Finn, I don't know, but this is your theory. So you would have to come up with a test of that explanation. Who knows how the creativity of the human mind works? People have suggested that the brain is doing something quantum. This is why it's so special and different. We can't rule it out. We have no good explanation that it is. Who knows how creativity works? Perhaps there's something involving interference going on at the level of the neurons. I don't know. No one has a good explanation. It's interesting to speculate, but at the moment, all we have is just complete and utter speculation. Many of us guess that the human brain is running a mind and all of it is basically classical. That's all you need. I mean, and one reason why I say, and again, this is not a knockdown argument, is because hitherto all models of experimental quantum computers require entanglement to happen. Entanglement seems to happen at low temperatures where the noise is reduced and the brain is a very noisy environment. Now that again, that's just based upon current understandings, which is all I can go on is current understandings. It might very well be that next year someone figures out a way of maintaining entanglement inside systems that are operating at room temperature or higher, just as they seem to be able to do with, well, not quite, but as has been the progress with superconductivity. Superconductivity, the temperature just keeps on rising and rising. I don't know what the latest is, but yeah, they continue to improve. Okay, so I'll just skip down because, thank you, Finn, but you did write a lot. Finn, all I can say is you could be right. He suggests that maybe thinking has something to do with qubits. When you're in a state of meditation, you're in a superposition with parts of the multiverse. This all could be the case. So I'm just going to skip past that. I don't know. No one knows how the mind works. And if you did have a theory of exactly how creativity in the human mind works, if you had such a theory, then it would be incumbent upon you, it's incumbent upon the theorizer of a purported scientific theory to demonstrate how it's scientific. And the way you do that is by also coming up with the experimental test, which can be very hard, to think of how one might go about testing your particular theory. But if you want to be taken seriously as a scientist, even as a theoretician, it's important for the theoretician to at least in principle say how their theory could be tested. You don't have to get into the nuts and bolts of what precise equipment you would use, but just to say how it might be tested. Excuse me again while I have a drink. Okay, Finn moves on to another question, series of questions. He says, are black holes parts of the universe in which a person, by David Deutsch's definition of a person, which I'd say could include all people and animals and atoms and life on Earth, is in a state of singularity with the space and time in which it extends to? David Deutsch's explanation of a person is that we are universal explainers. That is the new, and I would say most advanced understanding hitherto of what a person is. It's been a mystery that has plagued philosophers ever since there's been philosophy as to what makes a person different. And I think a lot of people have come to this via different angles. They've said, well, people are the only things with morality. We're the only ones that care about each other, unlike other animals. We're the only ones that can create poetry and music and art. These kind of answers are all orbiting the deeper fundamental explanation, which is about explanations. And David says, what we are and what a person is, whether alien, artificial general intelligence, or human being, is that we are universal explainers. Anything that can be explained, which is every phenomena in physical reality, can in principle be explained by us. Not right now, that's our whole purpose, is to try and create these explanations, but nothing is beyond our capacity to understand. Hence, we're universal explainers. That's what a person is. And nothing else counts as a person. But that's our best understanding. Now, is that a definition? I don't say it's a definition because that would mean that somehow there's a finality to it, but we don't know how explanations are generated. We know that we do it, and in order to be a person, you have to be something that can generate explanations. But exactly what it is that people do in creating explanations, we don't know. That's an open question. Many more questions. I'm skipping Finn to just perhaps someone can answer. He asks, is the universe expanding at an ever-increasing rate because black holes are ever-increasing the rate at which they become singularized with their surroundings? No, the universe is expanding at an ever-increasing rate for reasons we do not know. We call the problem dark energy. Something is driving the expansion of the universe, and we don't know what it is. The amount of energy in any fixed volume of space remains constant. This is why, hence the term dark energy. It's like, where is this extra energy coming from? Because if the universe is expanding, the energy density of the universe should be going down because there's an increased volume and you have to spread this energy over a greater volume, but that's not what's happening. The energy density of the universe is remaining constant. Okay. So I think I'll end it there. Finn, feel free to contact me again via Patreon or some other method, and we can have a perhaps private conversation about the rest of that. Now, having said all of that stuff about from Patreon, let me now go to any questions that happen to have been asked on the chat over here, which I haven't been paying attention to. Vicky has asked, what are your thoughts on human biases which lead us humans to irrational decisions? I follow in the steps of David Deutsch here in saying that a bias is just a word people have invented for a certain kind of error. I think the mistake that people make, bias, if you will, that people who talk about biases, is that they think that it is some inherent problem with people, that people are people are prone to just continually make these mistakes. But once a bias has been pointed out to someone, they error correct. It's just an error. It's just a mistake. And so people are plagued with errors, but that's the necessary state of being a creative person. The only way of being creative is to conjecture, guess something, and more often than not, you're going to be wrong. You're going to make a mistake. Now, some people tend to not correct particular errors, which itself is an error, and repeatedly not correcting a particular error, some people diagnose that and give that the label bias. So, I don't think it makes people especially irrational at all. There could be some good biases in the world, but parents are rightly biased in favor of their children. Now, does that make them irrational? I don't think so. I think it makes them perfectly rational, but it's a good bias, right? You should want to spend more of your income on your own children than on some stranger. It's the right thing to do. That's the way in which society and families cohere, and progress happens and problems are solved and people are nurtured and so on and so forth. I think that's quite right. So I don't call that irrational. I call that rational. So not all biases are indications of irrationality. And those ones that are indications of irrationality are again just mistakes, just errors that one might make. So people write books and books on biases and on what do they call them, logical fallacies and that kind of thing. And it's all just different kind of errors that people have put labels on. My series on Pinker's book, Rationality, goes into this to some extent. And I get worried about it because, as I've been trying to explain there, it does tend to create, and this again goes to the issue I was talking about earlier about how sometimes experts are their own worst enemy. They're not doing themselves favors, because if you have this concept of logical fallacies and you'll be a critical thinker or a good thinker or a rational person, if only you learn the list of logical fallacies and the biases that people are prone to, and if you learn these things, then you're one of the rational people, you're one of the good people. But everyone else those ignoramuses, the plebeians out there, the uneducated and unwashed. Well, of course, we luckily are here to help them because we are less prone to error. We understand the logical fallacies. We are not so prone to irrationality. Us, the experts, the intellectual class. This is the sense in which, even if they don't explicitly say this is the sense in which they're not doing themselves favors because they can come across that way. There's something to be said for a certain level of modesty. Popper was absolutely right in saying, while differing widely in the little bits and pieces that we do know, we are all equal in our infinite ignorance. We are all equal in our infinite ignorance. Now, of all the people that need to know that is the intellectual class, the academics and the experts. They need that lesson more than the average person, I would say, because they tend to forget that the little bits of knowledge they do have, the bits of expertise that they do have, does not make them less prone to error. In fact, if you want to talk about bias and error that is repeatedly made, then it's the bias of the intellectual at times, presuming to know best, perhaps especially about their own area of expertise at times. Because having an area of expertise makes you sometimes uncritical, makes you a little bit too comfortable in knowing what you know. It's good to have the crank and the skeptic and the layperson out there questioning, coming along and say, I don't agree with you. And it's wrong to try and silence them. It's wrong to say, you're an irrational person prone to bias. I'm an expert. How dare you? This is the attitude. This is the very religious type way of thinking. That the priest is the one who is only capable of properly reading the Bible and understanding the mind of God. The scientist, the only one capable of understanding the book of nature. This mistake, this error. We need to guard against it. We need to remember that we're all equal in our infinite ignorance. And when someone appears to be irrational, making wrong decisions, patience, kindness, carefully explaining one's position, not insisting that you know what the future holds and that you have some special ability to predict what the future holds. Okay. Next question. Remy has said, perhaps what I'm asking of the schooling system is something decentralized science. Absolutely, yes, totally on board with that. And of course, this is one of the great things about the free market and what the free market actually solves. If you have a focus on government-funded research, well, I could spend an entire another, how long have I been going for now? 2 hours. I could spend another 2 hours talking precisely about this problem. I won't. But the issue is that if you're handing out tax money for the purpose of research, then quite rightly, the taxpayers and the politicians want to know where it's going and precisely why. They want to know what problem you're solving by doing your research. But the thing is with fundamental science that you don't necessarily know what the end point is going to be. All you know is that you don't know what the answer to this question is. You don't have an operating theory, but you need a little bit of time. Therefore, you need a little bit of funding in order to come up with some suggestions. Quite rightly, taxpayers going to work 9 to 5, bringing up families, earning the bare minimum, paying off their loans, struggling these days with inflation to get the basics at the grocery store. Quite rightly, they would think, why is my tax money going to this group of people at this university over here if they can't even say what they're going to do, what the solution is going to be? So again, there's this tension, but this does not arise to some extent, to some large extent, in the private sector. Because in the private sector, you can have the generous benefactor, the philanthropist, the person who says, I recognize your potential genius, your creativity. Here, I'm sponsoring you for the next 5 or 10 years. Go for your life, do your best. Now, there's no guarantee that at the end of that, this scientist or research group is actually going to produce the goods. There's no guarantee. There are no guarantees in life. But the philanthropist, the wealthy person, the corporation perhaps, who has some good ideas about how to help foster fundamental science, then they're going to assist in the flourishing of the creation of knowledge in that way, in a way that I think it would be unfair, it is unfair for people grinding away at much more boring jobs don't have the opportunity to do yet. And one day we'll all be working on creative stuff. Great, but we're not there yet. And so for that reason, I think that where we can, government funding should be replaced by private institutions. Now, at the moment, we're not there yet, and I would say that any such transition, it's not happening anyway, so what's the point of worrying about it? If anything, government funding of science is only increasing. I'm not a dictator. I have no power whatsoever. Even if I did, it would be an incremental decrease in the other direction. I think that what universities and government-funded research institutions are doing right now is great for the most part. Wonderful. Do I think the Large Hadron Collider should have been built? Yes. Do I think the Hubble Space Telescope and the James Webb Telescope should have been put up there with government funding? Yes. Why? Because at the moment, there is no private institution willing to do this. But if they weren't paying so much in taxes, maybe they would. Maybe they would. And this has been my argument about that kind of thing for a long time. That generosity would absolutely flourish if people were able financially, from corporations through to individuals, to be more generous. But they can't be because so many are struggling to make ends meet. Corporations are struggling to make just enough profit to keep themselves in existence. Individuals are struggling to make just enough income to pay the bills. So they can't be generous. Everyone's paying so much tax. That's that. Let's see. Jojo Monster, Quadruple 7 has asked, are you generally interested in spreading your ideas? For example, if a big live stream with 5.9k viewers, 440,000 subs, wanted to interview you, would you be up for that? Or would you not care about that? Well, of course, I like in talking to people, and I do talk to people. I talk to people all the time about this kind of stuff. It's not that I tend to turn people down who ask to talk to me, but I've done it on occasion only because I think that, well, perhaps our interests aren't the same kind of thing. A lot of people like to talk politics and political stuff and contemporary issues, and while that's all very good and I can engage in that stuff, for now I see my role as, well, doing what I do, and that takes up a heck of a lot of time. I'm in the midst of editing yet more episodes on my series on the fabric of reality, which is what I absolutely love doing. I think it's really important that these ideas do get out there. So yes, of course, interested in spreading my ideas. Pratap Singh has asked, are there more episodes coming with Naval? What I'll say on that is just stay tuned. Stay tuned on that. So be a little bit a little cryptic. Yeah, I think that's it. I think we're down to all the questions. Christian Dean asks, true or false? Intelligence is not greater or lesser cognitive superiority. True or false? Intelligence is not a greater or lesser cognitive superiority, but rather specific knowledge about how to pass the social test we call intelligence, articulate, read behavior. Yes, absolutely. I agree with you, Christian, entirely. I've spoken about this reasonably extensively on my blog and channel, podcast, and so on and so forth. What I admit to the psychologists and to various others who are absolutely dogmatically committed to the idea that IQ is a thing and intelligence differences are real, is that it can be predictive. Of course it can be predictive. Of course it can be predictive. Anything can be predictive. But that doesn't mean it's explanatory. Now, if you perform well on a particular test, you have to ask why. Why did you perform well on this IQ test? Now, on the account of certain neuroscientists and psychologists, it's because of genetic differences between people. But that's not the case because of explanatory universality. People are all equal in their infinite ignorance. People are all equal in their capacity to explain stuff. Intelligence, on my worldview, is a black and white thing. It's not a grayscale. Knowledge content is a grayscale. People can know more or less stuff. And the more stuff you know, the better you'll perform on IQ tests. And that's all there is to it, I would say. Now, people deny this and they say, no, it's genetic, we can show that it's inherited, and that's a whole other story. But I agree with the underlying assumption of Christian's question there. It's specific knowledge, and you can practice the style of questions that are asked in IQ tests and improve. Your genetics won't have changed, but your performance on the test will have changed because you've learned more. Maybe there are some questions on Twitter I may not have gotten to, so just to finally get through everything there. Jitin has asked, Jitin, another great supporter of the podcast, what are your thoughts on what addiction is? Why do gamblers, people using drugs, etc., need help with addiction? I think that I accept what the neuroscientists and psychologists tend to say on this, that there are two kinds of addiction. There would be a chemical kind of addiction and there would be a psychological kind of addiction. The chemical kind of addiction is where you've been consuming a particular chemical for some time, alcohol, heroin, whatever. And by virtue of repeatedly ingesting that particular chemical, it has physically altered the chemistry of your brain. It has replaced the usual functioning of neurotransmitters. So that if you were to suddenly take away the alcohol, then the neurotransmitters that were hitherto being provided and stimulated by the alcohol are no longer present. And that could cause death because now your brain, which controls the rest of your body, is no longer functioning in just the same way. So that's a physical form of addiction, and it will be felt as a compulsion to consume alcohol or to take the drug, whatever it happens to be. And so that is a genuine physical addiction, a medical issue. And it has a good explanation behind it. Then there is the other kind of addiction, which is the psychological addiction, where, and I think many more people, I would say, likely have this, which is a form of thinking you need the thing in order to get through the day or through life or whatever. Again, alcohol. I think possibly a lot of people are psychologically addicted to alcohol. That if you took away their alcohol, it's not like they're suddenly going to collapse and have seizures because their brain chemistry has been mucked up so badly. But rather they feel as though they won't be able to enjoy life without it. And so they continue to go back to it again and again and again, just because it feels good. And they are under the mistake. They have the mistake that they're carrying around it, which is, I can't enjoy myself without this thing. I need to have this thing or life won't be fun, which is just an error. Now, it might be true that for the next few days, they won't know how to have fun. This is true in social situations. Certain people will always have alcohol in social situations. They simply don't know how to participate in social situations without the alcohol, or better, don't know how to have fun in social situations without the alcohol. So that can be a form of psychological addiction. So I'm not adding anything there to what I think is well known in the scientific literature. Why do they need help? Well, people need it for two reasons. One, the first kind, the physical kind, is because it's a medical issue. And so there needs to be a way of weaning people off. And I think that is a problem with a well-known solution. In the case of alcoholism, slowly tapering away the alcohol and replacing it with other medications, which themselves are gradually reduced until you're back to normal and you're dry or sober or whatever it happens to be. Why do other people who are psychologically addicted? Because you don't know how. It's like anything else. People need help with, let's say, gambling is a good example. Why do you need help? Because you don't know how to enjoy life or move through life without doing that thing. It's like, well, why do some people need help going to the gym and exercising? Well, some people just don't know how to get into a routine. This is psychology and counseling at its best. I spend a lot of my time criticizing psychology qua science, as an explanation of how the mind works. I think they get a lot of that wrong. But at its best, psychology provides psychologists who are wise, kind, compassionate people who will help talk you through your problems and solve them, help you, in partnership with you, solve your problems. And so that's the case with gambling as well. Let's see. Michael Felber, thanks for the amazing work explained, David Deutsch's and I think that's Chiara Marletto's thinking. How is David Deutsch's multiverse compatible with hard to vary explanations? If already answered, please point me to the episode. Well, I suppose I can point you to, again, my series on the multiverse. In very brief, why is it hard to vary? Well, the way I typically explain it is, well, if we just ignore the experiments for the moment, there's only one way of explaining the outcome of the experiments, which is to infer the existence of objects that we cannot observe there in the multiverse. But to take the equations of quantum theory as literal descriptions of what's going on. So in the same way as Kepler's laws of orbital motion imply the existence of orbits, so that when something like Earth goes around the sun, it only occupies a particular place at a particular time. Nonetheless, the orbit is real because all the other places at all the other times really do exist. We've either already been there or we're yet to get there. So an orbit exists. We just take seriously what Kepler's laws say, and we arrive at the conclusion an orbit exists. In the same way, there's something called the Schrödinger wave equation, which implies that for any object, take an electron, it simultaneously occupies many different positions, okay? Many different velocities, has many different values for other physical observables. But take position. The equations say it's literally in multiple positions at the same time, but we only ever observe it at one position, in the same way that the Earth is only ever observed at one position in its orbit, even though the orbit exists. All the other positions really do exist. Well, so too with the electron. If the equation says that it occupies all of these places simultaneously, then simultaneously it does occupy all these positions. Hence the multiverse, but we only ever observe it in one place. So that's the hard to vary explanation. And that's it. That comes to the end of the Ask Me Anything. Thank you to those who tuned in for part of my little diatribe today. And I think I've set myself a new record at 2 hours and 20 minutes. For anyone who did make it this far, tomorrow, hopefully, we'll have another episode of discussions of the fabric of reality out. And 2 should come in fairly quick succession, because I've been rereading through some of Popper's old material that comes to bear on David's chapter 7, A Conversation About Justification. So that'll be the next episode that's out, heavily focused on some stuff that Popper said about this. But until then, I'll see everyone later. Bye-bye.